Something that's new to Year 12 methods that hasn't been covered before is something called probability distributions. Now, probability distributions doesn't introduce any new concepts in terms of the probability calculations. It's just a neat way of describing our whole problem. So we can see here, we've got this table that has two rows. Got this first row that's labeled X, and the second row that's labeled with the probability of capital X equals lowercase x. So obviously the first row represents some sort of variable, the second row represents some sort of probability, but it's a bit hard to determine how to structure one of these without knowing what each of the x's represent, especially because we've got the same variable, except one's just capital, one's lowercase. So let's just describe them in general. Capital X represents your event. So the event might be rolling a die, let's say. Now lowercase x represents a specific outcome. So one of the specific outcomes of rolling a die is maybe rolling a 1. So the top row of your table fills up with the different possible outcomes, and this should cover all possible outcomes in the experiment or in the event. So in the event of rolling a die, this should cover 1, 2, 3, 4, 5, or 6. Now, the corresponding probabilities are really easy to calculate. In this case, they're all equally probable, so we know that all of these will be 1/6 respectively. Now, the table needs to describe all possible outcomes to an event or an experiment. And to ensure that, or to double check that we've done that, it's good to calculate all the probabilities or add them all together and see if they add up to 1. And we know that probabilities always have to add up to 1 when covering all possible outcomes. So in this case, you can see if we add all of these together, they would add up to 1. And it's pretty obvious that we've covered them all because we know a 6-sided die would only have numbers 1 to 6. Now, this example was pretty easy. If we wanted to calculate something, or if we wanted to calculate anything, it's very standard and exactly what we've known from before. The notation might be different. So for example, the probability x equals 1, that's literally just saying what's the probability of rolling a 1. And we just get the probability that corresponds to that column in the table. That'll be 1/6. Something that's a bit more complicated might be the probability of rolling x greater than 3. So that'll just be covering 4, 5, and 6 because it's strictly greater than 3. So this will just be 1/2 if we add them all together. So it'd be the probability of this one, 4, plus a probability of 5, plus a probability of 6. And again, we could do the same thing for more complex things such as intersections and conditional probability. But again, this example is pretty straightforward, so it's a bit hard to see any sort of complex things going on. Sometimes we won't have equally probable events either, so in this case we actually don't. In this example, we're asked to describe the probability distribution of flipping X heads when flipping a fair coin twice. When I ask you to determine or describe a probability distribution, it's literally just saying, make that table. So the variable that it uses is X. Note that sometimes it might be different to X, sometimes it might not state a variable. In this case, it's given to us as X. So the first row on the table will start off with lowercase x to represent our specific outcomes. The next row would be capital X equals lowercase x. Again, our outcome equaling a specific event. Now, what are the possible values for X, or what are the possible number of heads that I can flip when flipping a fair coin twice? Obviously, I can have 0 heads because I can have 2 tails. I would just write that above it. You don't need this for the table, but it's good for reference. If we have 1 head, then it could be head, tail, or tail, head. And if we have 2 heads, or X is equal to 2, we'll obviously have head, head when we flip the coins. Now, let's get the hardest one out the way first, which is the one with 2 combinations. Probability that X is equal to 1. So it'll just be 1/2 multiplied by 1/2 plus 1/2 multiplied by 1/2. The probability of each of them respectively added together because it's 2 different combinations that you can have. 1/4 plus 1/4 is equal to 1/2. And if you complete the same process for the other entries in the table, you just get 1/4 for each of them respectively. And now we've calculated our probability distribution for flipping heads when flipping a fair coin twice.